Video lesson 11.3, evaluating piecewise functions. So when we're going to go through these piecewise functions here, sometimes we can evaluate them algebraically or graphically. So in order to do that, let's just think back for a second though, and think about what would you do if you were just asked to evaluate a function normally. So in this first one here, I've got 2x squared plus 3x minus 5. So if I evaluate the f of 0, so that's what that's saying is, what is the function of f of x when x equals 0? So what do? We just simply plug in 0 for all of the x's and simplify, right? 0 squared times 2 is 0, plus 3 times 0 is 0, minus 5. So therefore, f of 0 would be negative 5. And what does that mean? It means that when x is 0, y is negative 5. We can look over here at this one. So this would be 2 times negative 3 squared plus 3 times negative 3 minus 5. Now, one of the things that you want to be extra diligent here is when you're plugging these in, especially with negative numbers, especially if you're plugging it into the calculator itself, you want to make sure that you use parentheses so you don't make any calculation errors or anything like that. So negative 3 squared is 9 times 2 is 18. 3 times negative 3 is going to be minus 9 and minus the 5. So that's 18 minus 14, which is just going to give us, was that 4? So f of negative 3 is 4. So that's the evaluation portion. That's what we've done in the past. So we're going to do that same thought process here when obtaining it for a piecewise functions, except, all right, we have to make sure that we plug it into the correct portion of the domain. So look at example number 1 here, right? You want to evaluate f of 0. So I just have to be conscious of what the restricted domains are, right? What is the portion? Where is the 0 going to work? That's the key. So in this case, what 0 is when x is less than 4 and x is greater than or equal to 4. So 0 will fit in this portion of that condition. So therefore, I'm plugging it into the top part of the function. So this is going to be, in this case, 0 plus 3, right, for my evaluation. So f of 0 is just going to be 3. If you plugged it in down here, mathematically you're going to get an answer, but you would never be plugging it in because 0 is not part of this restricted domain for that one. So that's why it's not going to work there. Right? If you look at 10, right, where is 10? 10 fits in this portion of the restricted domain. So now I'm looking at the bottom part. So now it would be 2 times 10 plus 7. So that's going to be 20 plus 7. So f of 10 is 27. So that's where you have to be really, really careful, is to which portion are you going to plug it into. Lastly, this one, which is a common question, is what happens when you plug in this case, 4. Now, at first glance, it looks like both of them work, but it only works in the bottom portion because this one here has the greater than or equal to. So that's the part that's going to work here. It's not included in the top. It's just less than on the top part. So it's going to be the 2 times x. So in this case, 2 times 4 plus 7. So that's 8 plus 7, which means that f of 4 equals 15. So you just got to be really diligent about where you plug it in and with respect to its particular domains with respect to each part of the function. All right, look at number 2. Same thing, just a little bit more involved. Right, so first one here is f of 1. So which one where does 1 fall here? X is less than or equal to negative 2, negative 1, 2, 3, and then from x is greater than or equal to 3. So this first one's going to fit inside this portion. So because 1 is between negative 2 and 3. So I'm going to plug that into the 4x squared part of my function. So that means 1 squared is 1, so that's going to be 4. All right, second part, -5. All right, where is -5 land? Well, -5 is less than or equal to -2, so that's going to fall in this portion. So I'm going to plug that in. Now it says here, the f of x, the function is just 5, aka like y equals 5. So that means anything you plug in here where x is less than -2 or equal to -2, every answer is going to be 5. So this was a nice easy one, nothing to do except notice that you have a linear horizontal function going on right there. All right, next, f of 3. Again, be careful. At first glance, you might jump to your eye might jump to here because you see 3 is part of your restricted domain, but it's not included. It's just less than. You have to go down here. It's greater than or equal to 3. So I'm going to utilize that bottom function, the 7x plus 3. So we're going to plug in 3 for the x. So that's 21 plus 3. So f of 3 is 24. All right, and last but not least, we'll do this one as well, f of -2. Again, included here because it's less than or equal to -2. So again, that's just going to be 5 because again, that's the horizontal line. All right, so what happens if the question looks like this? It says f of x equals 10. What does that mean, right? This means here, right? In this case, it's saying, what is x when y equals 10? All right, y is your f of x function, right? So we're working backwards here. These sometimes can get a little tricky, especially the more elaborate the function is. This piecewise function is going to be. So what we're going to do is we're going to take each portion, right, and set it equal to 10, right? So I'm going to take each part of these things. So the first part is the top portion here is 5. So I'm going to say 5 equal to 10. Is that possible? No, it's not. So 5 is not equal to 10, so we drop this. It fails. So that means that you cannot have an x value, right, that is less than or equal to -2 and get a result that is 10. All right, let's try another one here. So let's do the second one. So 4x squared, when does that equal 10? All right, so if I divide each side by 4, I get x squared is equal to, that's going to be 2.5. I take the square root of that. I get x to be approximately, let's take the square root of that value. It's approximately 1.6. So is this inside my restricted domain? Is 1.6 inside of this portion of what x can be? It can, and 1.6 does land inside of there, so therefore it does pass, right? So that means that it is possible to have an x value of approximately 1.6, and when you plug it in, you would get a value of 10. All right. Now I have to also check the last one here as well. So I got to check down at this last portion. All right, as here. So 7x plus 3. When does that equal 10? All right. Subtract 3 from both sides. 7x equals 7. So x would equal 1. So I get an x value, right, for 1. So does that mean that this works? Well, again, just because you get an answer doesn't mean it works. You have to check to see, does this land within this restricted domain that they gave me? And for this bottom x plus 7x plus 3 portion of the function, x can only be greater than or equal to 3. 1, this is not greater than or equal to, rewrite that. This is not greater than or equal to 3. So therefore, not possible in this case. All right, so this one fails. So the only one here that does work is the middle function, and x would be approximately 1.6. So this is definitely a tricky one, right? You have to be careful. Again, the more involved this piecewise function is, the more work you have to do here. Like for example, there was 5 sections of this piecewise function. I'd have to, test this for all 5 of them. So it does get a little bit of an annoyance sometimes. So you have to be mindful of that and try to process through it as best as possible. But again, the concept is there, is what we're looking for here. And what I'm really important is to make sure that you understand that this is saying when y equals 10, what is x? Okay. All right, let's look at this also from a graphical standpoint. All right, so if they gave me this without the functions algebra, or I'm sorry, the equation of the function, we can actually just look at the graph. So when is f of 0? So when is the x value 0? So here's my x value of 0. All right, I look and say, what is my y? Where does this work? It works right there. So therefore, I get an answer of 2. When is f negative 1? So I go over here. Where is x negative 1? X is negative 1 right there. I scroll up. I see 2 spots, here and here. But this top one is an open circle, so that doesn't count, right? So it's only this one here. So where is that y? That y is 1. So if x is negative 1, my y is 1. All right, well, what if they say the reverse? So again, what is x when y, right? This is just y, equals negative 2. So again, now go to negative 2 on here. So this is negative 2. All right, look left and right. Well, this one happened to land right on it, right? So when is it negative 2? When x equals 0. All right, which is actually just the reverse of what we just did up there. All right, when is it equal to 3? When is y equal to 3? So again, go to here. Oop, I'm sorry, I take that back. I lied about this one. I did 2. We wanted negative 2. Sorry, let's go back and fix that. Negative 2, 1, 2. So when is it negative 2? Well, I gotta look left and right. I have an answer here, and I have an answer here. So I touch the graph at 2 spots here. All right, one is at this location, one of them is at this location. So that's 1, 2, 3, 4 on my x-axis and negative 2 on my x-axis. So x could equal negative 2 or 4. Both of them are possible answers for here. Well, does that mean it's not a function? No. Remember, you can have multiple the x values. They can only pair with one unique thing. So each of these is uniquely adding to negative 2. These values of x are not having multiple answers. They're just, the y's can be duplicated, but the x's cannot. All right, back to this one over here. When is y equal to 3? All right, so I go, where is it? 3, 1, 2, 3. Here, right? I look left and right. Where does it work? Well, I see, again, it's here, but that's an open circle, so we can't include that. I've got nothing else over here, so the answer is does not exist, or never in this case. So when can x, what would x be when this is? Yeah, it does not exist. I'm just going to abbreviate that as DNE, right? Does not exist. Because, again, there's no x value I can plug in to get a y value of 3 because we have an open circle here. So because I have an open circle, right, that means there's no value actually there. All right, so that was a little tricky one on that one. All right, let's try this graph over here. All right, so one is f of 3. So again, looking at my x-axis, here's 3. Where do I get the graph? It crosses right there. So my y for that is 0. So that would be 0. When is f of 5? So when does x equal 5? So go to 5 on my x-axis, look up and down. So I get it right here, right? So if I look over here, that gives me negative 2. My next one, what is x when f of x is equal to -1, aka when is my y equal to -1? So go to my y-axis, look for -1. I scroll, in this case, left and right, so I can go all the way over to here, right? And that gives me an x value of 4. So when x is 4, y would be -1. All right, and once again, what is x when y is equal to 2? So again, go to 2, look left and right. Now here, you can see I got 2 possible answers, here and here. So now I got to look down, right? So it looks like it's approximately -1 and 1 for both of these. All right, and I just use the set notation bars to represent multiple answers there. All right. So again, hopefully that's not too bad for you. Again, it's a little bit of practice, kind of looking and involving. Obviously, when you don't have graph paper, you know, grid lines, you do have to be a little extra diligent and cautious when you're doing this. You know, you got to be as accurate as possible. And there, if I was to land kind of like in the middle, obviously, I'm going to approximate that, something of that nature. So be careful there. All right, last thing, just dealing with, again, just kind of incorporating transformations with our piecewise functions. Again, these are all the ways that we could, you know, visually or symbolically represent transformations, whether they're vertical translations, horizontal translations, if they're compressions or stretches, if they've been reflected or compressed, or, you know, reflected over the y-axis, and so on and so forth. So just kind of looking at these. So I just put 2 quick examples here for us to do. So both of these, the black graphs are the original y equals f of x function, piecewise function, and both of these have obtained some type of transformation going on. So for the first one here, a of x is the f of x function plus 2. So this plus 2, right? Again, it's on the outside. It's having to the outside of the function, right? So that makes this a vertical, right? A vertical translation up 2. So every point that I have, I'm going to move up 2. So 1, 2 here. I got a point here. I got a point here. I got a point here. Everybody went up 2, and now I can connect everybody together using a straight edge, and that would then be a of x for that one. All right, over here, all right, it's inside the function, right? It's inside, so that makes it a horizontal translation or shift. And again, it's opposite what you think. So a minus means right. So subtraction or a negative means we're going right 2. So now I take every point, I move it 2 to the right. 1, 2, 1, 2, 1, 2, 1, 2. And now I can connect all of them again with my straight edge. So it's going to look something like that. So again, just going to be able to do that for each one of these things. You know, when dealing with, if you do have a compression, so if this was like 3 times f of x, for example, you know, you got to pay attention to where it's being multiplied. If it's being multiplied on the outside, right, then you're just going to have a vertical stretch, so you're going to increase this up or down in terms of it being stretched out. If it was, that means the y portion. If the multiplier was inside the function, so if it was like f of 3x, for example, then it's going to be inside. That's a horizontal either stretch or compression, so that would be happening to the x values. So you would just simply multiply those points, the x and or the y respectively, to those, and that would allow you to kind of shift it around there too. So you know, if it's a reflection, you know, again, if it's over the x-axis, it's just a flip, you know, however far it is from the x-axis, you do the same distance away. Same thing for the y. If it's, you know, how far it is from the y, you would do the same distance away from the y, and that would be your reflection from there. All right. So again, just take an opportunity to look through the video. If you have any other questions or need to go through anything a little more, feel free to go back and look it over. And don't forget to utilize practice problems for better understanding.